probably heard that you can determine a tree's age and when it's had good years of growth by examining its rings. But where do these rings come from, and why are they so revealing about the life of a tree? Most land plants, including trees like this coastal redwood, are part of a phylum called Tracheophyta, meaning they possess vascular tissues called xylem and phloem. Xylem conducts water, while phloem conducts photosynthase. As tracheophytes grow in length, a process called primary growth, more xylem and phloem are produced from a region of tissue called the procambium. The procambium is meristematic, meaning that rather than maturing, its cells continue to undergo cell division, or mitosis, to produce cells that eventually mature into xylem and phloem. The procambium and other meristematic tissue undergoing mitosis is what allows this sword fern to grow from a few small fronds into a mature fern plant, and this sapling into a tree hundreds of feet high. But unlike the fern, this sapling's procambium allows it to undergo another process called secondary growth. In this sapling and other woody plants, the residual procambium left over between xylem and phloem from primary growth gives rise to a region of tissue called the vascular cambium. In the cross-section of this pine stem, the vascular cambium appears as a thin layer of cells between the xylem and phloem, forming a continuous ring around the stem. Like the procambium, the vascular cambium is meristematic and produces xylem and phloem by undergoing mitosis. However, unlike the procambium, which produces tissue for longitudinal growth, xylem and phloem arise on either side of the vascular cambium for lateral growth. That's how this sapling's trunk can not only grow several stories high, but have a massive circumference as well, whereas the sword fern does not increase in girth as its stem elongates. To differentiate between growth for elongation and growth for girth, the xylem and phloem produced from the vascular cambium are called secondary tissues. One of the conducting cells of xylem are called tracheids, and in secondary xylem, these cells are produced inward of the vascular cambium. During the spring season, when there is more water and sunlight available, larger tracheids are produced and subsequently decrease in size as the days get shorter and there is less rainfall. When spring comes back around, the vascular cambium makes larger tracheids once again. This repeated changing in tracheid size throughout the season gives rise to the ring-like patterns we see. While this pattern can provide an approximation for a tree's age, in years with low rainfall, the vascular cambium will produce smaller tracheids, thus influencing the size of the annual ring. Examining rings on a cellular level is helpful for understanding the life history of a tree and can reveal how phenomena like climate change are affecting secondary growth. So next time you see a growing tree, consider its surroundings and the kind of weather it's exposed to. Was this a good year for its tracheids? Thank you.